Okay, good evening. Since I forgot to videotape our lecture this morning, I need to do it for those of you who were gone today since there were so many of you. What I thought I could do, a more efficient way to get through the lesson without wasting too much of your time, was to look at homework examples that would correlate with your homework, and then you can get it done and learn the concept of equivalent fractions. Equivalent means the same as. It's not necessarily the reduced form, it's the same as. In other words, it's the same value no matter how many pieces you cut that fraction into, it has the same worth. So we got to look at the pictures, see where the bases of fractions come from. It's how many parts are shaded. You see there's 3. Over how many parts is this big rectangle cut into? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's always what fraction of it's shaded gold, that's the top part, and then the area is how many total pieces that it's cut into. This is another one. Goes fast once you know what you're looking for. I see 1, 2, 3, 4, 5 out of 7 total pieces, 6, 7, that are shaded gold. Got to read the directions because sometimes they ask for unshaded. So this time they just asked for shaded, so that worked. Whoopsie, got this thing going crazy. Okay, if a big rectangle represents the whole, they want to know, I'll get that back in there, what fraction of its area is shaded gold. If I can get my screen level again. I see 3 shaded out of 1, 2, 3, 4, 5, 6, 7, 8 total. So those are the pictorial representations of fractions. That's all a fraction is, comparing two relationships. How many and the parts over how many in all. So entering a fraction that's equivalent to 1/5 with the denominator 15, they means that when they change the fractions, look, they want to take those 5 pieces that it's cut into and cut it into 15 pieces. Denominator is the down number, so it goes numerator over denominator. So denominator is the down. Numerator, denominator. Numerator, denominator. So this, your calculator necessarily can't help you all the way. You can take the 5 times the 3 to get the 15. That means you have to take the numerator times the 3 to keep it an equivalent fraction. So they're fishing for the fraction 3/15. They do not want it reduced. They want a fraction that has the same value as 1/5, but with a different denominator. So a fraction that has the same value as 7/2, but they want the numerator to be 28. So I'm going to take this times 4 to get 28. And to keep this equivalent, I have to take the denominator times 4 as well. So I followed their rules. The numerator on top is 28. And then the denominator becomes 8 because of the story they gave us in the first place. 28 over 8. And don't hesitate to watch their videos as well. Rewrite the fraction as indicated. They already have it all set up. 10 times 4 is 40. So to make it equivalent, 3 times 4 is 12. Okay, this is number 7. Enter any fraction that's equivalent to 5/4. Just multiply them by any two the same number, but multiply both numbers by any number. So 4 times 3 is 12, 5 times 3 is 15, so 15 over 12 is an equivalent fraction. And you could do it by 100, whatever you want. Doesn't say what you don't have to multiply numerator and denominator by. Now we're getting into a place where the calculator can help you. If you just enter this into your N over D button in the calculator, it will reduce it automatically. But I can't show you my N over D button, so I'll just do it manually. I see 14's even, I see 18's even, so 7 over 9 is the lowest terms because 7 and 9 do not have any more factors in common besides 1. So read the directions carefully. Right, 48 over 16, lowest terms. That means reduce till you can't reduce anymore. So you can just divide by 2 or more since they're both even. But I notice they both have a 6 as a common factor. Can't do it unless they both have the same common factor. So 48 divided by 6 is 8. 60 divided by 6 is 10. They're still both even, so I'm going to have to reduce it just a little bit more. So I get 4 over 5. And if you would have put it in your calculator in the very beginning, you would have come right to that conclusion. Try to write even. I'm trying to write cockeyed. Okay, 11 divided by 11. That's all a fraction is a division problem. So 11 divided by 11 is 1. 16 divided by 1 is 16. So little quirks about fractions. 56 divided by 16, that won't go evenly, so you have to just start whacking away. If you could use your ND button or whacking away common factors. This is 28 over 8. And this is 14 over 4. Almost there. Sorry about the clicking. 7 over 2. So it does say express your answer as an improper fraction. That means the fraction, it's not a mixed number, but the fraction is got a larger value in the numerator than the denominator. So an improper fraction is when the fraction has an equal to or larger numerator. Okay, back to reducing. 8 goes into 32 4 times, but be careful. The 4 lives in the denominator. So remember, 8 divided by 8 is 1. 32 divided by 8 is 4. That tricks a lot of us. Here comes the algebra. If you have variables and numbers, you can do the 24 over 40 in your calculator and get it down to 3/5. But we have to ask ourselves, how do I deal with the variables? Well, variables are just factors that we don't know, and if they're each a term. So the factor of u divided by the factor of u, no matter what it is 1. So we can quote unquote cancel it. So the answer is just the fraction, 3/5. The u's have been canceled because they were the same amount of them. Okay, this one, and my word didn't convert very good. It should say 8u to the 5th over 36 u to the 3rd. That's another way to write it. And 8 and 36, they're both even. So I divide, they both have a 4, matter of fact. So I divide out 4 out of an 8 and I get a 2. 36 divided by 4 is 9. So 2 and 9 have nothing more in common. We're done. Now there are 5 u factors in the numerator. So it's like u times u. I'll write it up here. U. And down here, there's only 3 of them. U. So cancel one set of u's, 2 sets of u's, 3 sets of u's. So there's 2 u times u, which is u squared, in the numerator, and there's none left in the denominator, but the factor of 1. So the shortcut is just take the 5 minus the 3 and put the result as an exponent wherever the larger exponent lives. So I have 2u squared over 9. I have a couple more problems like that. Oops. Okay, this one looks like 15a squared over 18a to the 3rd. So we've got 15 and 18, they have factors of, I can take a 3 out of both. 5 over 3 out of that is 6. And it's 3 minus 2 is 1, but the larger exponent is in the denominator, so it stays in the denominator. So 5 over 6a. You put in your answer box. All right, here we go. 6, n to the third, b to the fourth, over 21, b squared, n to the third. So they're all just being multiplied. 6 and 21 have a common factor of 3. So that leaves a 2 and a 7. There's 2 b's down here, 4 b's up here. So that will leave b squared in the numerator. There's 3 n's and 3 n's, they cancel. So it's 2b squared, because 4 was larger, over 7. You know, between the two, it's 4 minus 2, but you put the result in the numerator because there were more b's in the numerator than the denominator as factors. So 2b squared over 7. There you go. That is the assignment. Thank you for listening.